Hey everyone, welcome to homework for your mid-unit assessment. This first part is just a review, so I am going to go over the first couple of problems, and then the rest I am going to expect that you try on your own because you can 100% do them. So let's take a look. If we're looking at the percent change from 45 to 92 feet, then we can say 92 divided by 45 gives us our factor. So the factor is 2.04, which means that it is growing to 204% of the original value. We can also say that the increase was 92 minus 45, and so it grew 47. 47 out of 45 gives us 1. Oops, oh no, that's 47, sorry, divided by 45. I was like, that's way too much. Okay, gives us 1.04. And we know because our rate is 1.04 or 104%. We add that to 1 to get our new factor. All right, so then if we have 74 to 85, the factor is the easiest thing to find here, because we can say 85 divided by 74, which gives us 1.148. And so then that means it's growing here by 14.8%. And then that means that my rate is 14.8. or 14.8%. Our rate, if we were multiplying it, would be 0.148. That's how much we are increasing it by, or 14.8%. And we can see that because 85 minus 74 gives us 11. So it grew 11 hours. 11 divided by 74 is 14.8, right? So that shows us the percent that it increased by, and then our factor is what we're multiplying it by. Okay, let me give you one more example. Here the factor, it's going to be greater than 1 because we see it's increasing, and so the factor is 1.01, we'll say. And so that means it's increasing. Notice 74 over to 75, it's increasing 1%. So my rate then is 0.01 or 1%. Okay? All right, so continue along that. These are all, or sorry, not all. These are growth factors, so you should have a factor that's greater than 1, right? And then a percent increase. And then these are this one right here, for example, and this one right here are decay factors. Things are going down. So you should have a factor that is less than 1. And in this case, we're looking at a percent decrease. All right, so make sure for each of these you show the factor and the rate. So then we're going to look at some visualizing percent change, and this is to help get you ready for tomorrow's lesson. So in this case, we're matching the situations to A and B. So in A, this is last year, that's 100%. And then this year, we are adding 25%. Okay, and so when we're looking at this, it says compared with last year's student population, this year's student population increased 25%. Okay, so that looks like a good one there. So increased 25%, right, is larger than last year's. B, this year's student population is 75% of last year's. So here we've removed 25%. So that is B, 75% of last year. Right? If this whole thing is 100, then this represents 25%. What's left is 75%. C, compared with last year, the student population decreased 25%. So here we have that with this decrease in blue. This student's population is 125% of last year's population. D, 125%. So we have 100 last year's population plus an additional 25%. So that part is done. Number 2 says draw a diagram to represent these situations. The number of ducks living at the pond increased by 50%. So if we have this year, or sorry, we have year 1, we'll say, and we have 100%. And then year 2, we increase, we have 100% plus 50%, and this bar should be about half of what, it's not quite right there, there we go, half of about this one. So increasing to this much of what it was originally, okay? The number of mosquitoes decreased by 20%. So again, we start with 100%, and then the second year, if it's decreasing by 20%, then our remaining is 80%. So you can show your diagrams in that way. Oops. Okay. All right, let's take a look now at computing percent change efficiently. So here, an article in the paper says the local high school's student population will increase by 10% next year. Diego knows that this year about 1,300 students attend the high school, and he wants to figure out next year's population. So he draws his diagram. This is 1,300, the 100% that exists this year. If we add another 10%, we'll have 110% of 1,300. He writes this as a problem. 1,300 plus 0.1 times 1,300. So this is taking the original amount plus 10% of 1,300. So step 1, original amount, or original number of students added to 10% of that number. Then 2, now here what he's done is, he said, well, I'm multiplying 1,300 in both of these terms. And so I can go ahead and factor out 1,300. And if I factor that out, 1,300 times 1 is 1,300. And 1,300 times 0.1 is 1,300 times 0.1. So here for this one, he factored out 1,300. Right? It's the opposite of applying the distributive property. In this case, he removed the common multiple from each of these terms, or factored out, right? Number 3, he combined 1 plus 0.1. Those are like terms, so he combined them to make them 1.1. And then number 4 says multiplying 1,300 by 1.1, he gets 1430. So this is just a simple step of multiplication. And the reason this is because 1.1 equals 110%, right? Remember that this is out of a whole, and so we're looking at that being, excuse me, 110%. All right, it says use Diego's method to rewrite each expression so that it only uses multiplication. So here, what's in common is 7, so we can factor out 7 and rewrite this as 1 plus 0.4, or 7 times 1.4. All right, this would be adding 40% of 7. So at the end, we have 140% of 7. Here, the thing that we have in common is 24. So we're going to factor out 24, and we have 1 plus 0.08, or 24 times 1.08. Here we have 13 minus 0.1 times 13. Again, the thing we have in common for both terms is 13. So I'm going to factor out 13, and we'll have 1 minus 0.1, which is 13 times 0.9. Right, that 1 minus 0.1. So in these situations, we were gaining a percentage, but here we're losing a percent, and so we will have what's left. So if we take 10%, then 90% will be left. And then here we have 98. We are again increasing here, so we have 1 plus 0.02, or 98 times 1.02. All right. The first calculation gives 7 increased by 40%. What do the other calculations give as a percent change? So this is increase by 8% for B. C is decrease by 10%. Remaining is 90%. And then D is an increase by 2%. And so multiplying a total of 102%. It says write equivalent expression using the distributive property. So again, same thing here. We're going to factor out 65. We have 1 minus 0.45. This says write an equivalent expression using the distributive property. So you can leave this as is because it's showing the distributive property here. If you want to rewrite it as 65 times 0. That would be 55. You can. All right. Here, factoring out 65 again. 1 plus 0.45. Here, now this one is interesting because we have times 1.2, so we can rewrite this as 91 times 1 plus 0.2, right? We can break that 1 and that 20% up. And then here, what we have in common is actually x, so we have x, and then 1 plus 0.04. All right. Number 7 says evaluate by multiplying just two numbers in your calculator. Write down the expression you calculated. So 130 increased by 10% means that we're going to do 130 times 1.1. So 130 times 1.1 equals 143. 25 decreased by 30% means that what is left is 70%. So 25 times 0.7 gives us our new value of 17.5. That's what is left. Now, when you're doing this, if you're not sure you did it right, it says decreased. So that amount should be going down, right? And it decreased by 30%. So it decreased a small amount, small percentage. So it shouldn't be, more than half of what the original amount was. 50% more than 38. So in this case, we have 38 times 1.5. Sorry, my kids are playing and they're being very loud. Times 1.5 gives us 57. And then 6% less than 200. So 200. And then we're taking minus 6%. So we're left with 94%. So 200 times 0.94 gives us 188. All right, the last part says write an equivalent expression that only uses multiplication. So you are still doing, all right, write an equivalent expression that only uses multiplication. In this case, we're using the thing that is common in each one of these is the variable. So P1, so P times 1 is P, minus 0.35. Because P times 0.35 is 0.35P. Here we can factor out Z. Z times 1 is itself, and 0.85 remains. Okay? You can rewrite these as P times 0.65 and Z times 0.15. Here we are factoring out Q. What's left is 1 plus 0.06. Or Q times 1.06, you can combine those, R times 1 plus 0.64, and then we can combine to make R times 1.64. All right, that is it for your homework. Today's code word is, let me think of a good one here. Nope, can't think of a good one. Today's code word is golden. Golden is today's code word. So type in the word golden at the top of your paper where the code word goes and you can earn extra credit. Happy homeworking and I will see you tomorrow.